Okay, so hey everyone, in this video I'll be going through basically the concept part only of the problem game on some easy version. So in the editorial, this part was one second, yeah. So this part was explained very much clearly why this holds. Like if I hope you all have read the question. So this is the question, game on some easy version. So in the editorial, this part is very much clear that if Bob decides to add something, then his forced number of adds won't actually subtract, like it won't be -1. So if he is adding, then the forced number of adds will get -1, and if he's subtracting something, then the number of adds still stay the same, which is j. These were the base cases, and so yeah, so let's just go through the concept and understand it more clearly. So from the editorial part, it's very much clear that dpij is actually minimum of two things. Is actually the minimum of two things, which is dp I minus 1 and j minus 1 plus x, because one of the adds has now has been wasted, and other one is I minus 1 and j. He's not adding, he's subtracting, so j stays the same and j minus x. So now in this question, it's not actually very much clear because x still has a range. Because x has a range, it can lie from 0 to k. So what should be the optimal value of dpi minus j? Okay, so just for simplicity and for explaining purpose, let's just consider this as 4 and let's just consider this as 5. This can be anything. These are two constants, C1 and C2. These can be anything. Just for the simplicity purpose, let's just say this is 4 and this is 5. So now we have two line equations, which is 4 plus x, and the second line equation, which is 5 minus x. Let's just try plotting these two values. Okay, we'll in the x-axis we'll be having x, in the x-axis we'll be having x, and here we'll be having the actual answer. Answer would be the minimum of these two things. So first let's just try plotting only 4 plus x. So I'll change the color. Okay, so let's just try plotting 4 plus x. If x is equals to 0, the value stays at 4. If x is equals to 1, it goes till 5. X is 2, it goes till 6. And now you have an idea what the graph is going to look like. So it is this. This would be the graph. Now let's try plotting the second graph, which is 5 minus x. So if the value is 0, it stays at this. Yeah, so it stays at this 5. X is 1, it comes down to 4. X is 2, it comes down to 3. Now you know the graph of this equation also, it is something like this. So now you know this is the optimal point, because suppose you consider x before this. What is the suppose you consider x over here. Okay, you consider x over here, then you actually have two options, this or this. You're going to select the minimum one, which is this point. Now if x is over here, you select an x greater than that optimal point. This is our optimal point. This is our optimal point, OP. And this is x1. If you select x1, the minimum of this value and the minimum this value is going to get selected, which is less than the optimal point, which will give you an answer less than the optimal point. And suppose you select x2, it will select minimum of this point and the minimum of this point. So again, it will give you a lower value. Only this value is going to give you higher value. So let me just draw it more clearly. These were the two graphs, this and this. This will give you the highest corresponding value of answer. Because you select anything before that, this particular graph is going to get selected. If you select anything after that, this particular this particular line is going to get selected. So the only optimal decision is to select this. It will give you the highest value. So now how to get that value? So suppose now, as we are done with the example, let's just get back to this. Y is equals to c1 plus x and y is equals to c2 plus x, c2 minus x. Now let's just find the intersection point. So just substitute y over here. What you'll be getting is c2 minus x is equals to c1 plus x, and x you'll be getting x as c1 plus c2 by c1 minus c2 by 2. 2 by 2. So now you actually got this. You got this. This is the value of x over here. This is. But we actually want this because this would be a dpij, right? This would be a dpij because we plotted these two lines. We plotted this line, and this would be a dpij, the intersection of these two lines. So now if we want to find the answers, just in any of these equations, just replace the x, So if I replace it in this equation, it becomes y is equals to c1 plus c1 minus c2 by 2, which is going to give you c1 plus c2 by 2. And now if you see closely, what is a y? Y is a dpij. What is c1? C1 is this dpi minus 1 j minus 1. What is c2? dpi minus 1 j. And in the end, we can say that dpij is equals to dpi minus 1 j minus 1 plus dpi minus 1 j by 2, which is the required condition in the editorial. This. So that was it. This was just a concept video. Thank you.